In this video, we look at the difference between linear and nonlinear data structures, and we try to get an overview of the different types of common data structures and conclude the series on the types of data structures. First example, consider the concept of an animation pane in Microsoft PowerPoint. I have 4 charts ordered as chart 1 first, then chart 2, chart 3 and chart 4. The order in which I want them to appear is, I want chart 1 to appear first, chart 4 which is in the lower right corner to appear second, chart 2 which is in the upper right corner to appear third, and chart 3 which is in the lower left corner to appear last. I have the ability to change the order in which the charts can be displayed. That is, I have changed chart 4 to be displayed first, followed by chart 1, chart 2 and chart 3, or chart 4, chart 3, chart 1 and chart 2. Here we have a list of elements where the elements are chart 1, chart 2, chart 3 and chart 4. The number of elements in the list is usually static. Also, there might not be many number of elements because the number of objects that we will see in an animation pane will be limited. The most common operation that is found in this animation pane is insertion, wherein in insertion, the minute I try to insert in an animation pane, it keeps inserted as the last element in the pane. But after that, I have the ability to move a particular element back and forth. I can move an element up in the list or I can move an element down in the list. I can delete an element at any place in the list. If you remember the data structures that we have learned, stacks allow insertion and deletion only at one place. Queues allow the insertion at one place and deletion at the other place. But when we say the generic term array, I can perform insertion and deletion at any place in the list. Similarly, move up and move down are also fairly easy operations in an array. A linked list can also be considered to solve this problem, but remember, every time a move up or a move down operation takes place, a node is deleted from its place in the linked list and it has to be inserted at another place in the linked list. This is a more tiresome process when we consider a linked list, so an array seems a more appropriate data structure in this case. Let's consider the second example. I have a function called as main, which calls a function called as print sorted output. Print sorted output calls a function called as insertion sort. Insertion sort in turn calls a function called as getInput. GetInput is a function which gets input from the user and it returns an array of elements to this calling function. So now insertion sort now gets an array of elements from getInput function. Using this array of elements, insertion sort performs sorting operation. After sorting, it returns the sorted array to the function that called it, namely print sorted output. Print sorted output takes the array which insertion sort has returned and prints the output onto the screen, and then goes to its calling function main and ends the program. What data structure is typically used in this kind of a scenario? The data structure typically used in this kind of a scenario, which is namely a function call, is the stack. To know that getInput has to return to insertion sort and insertion sort has to return to print sorted output and print sorted output to main, we make use of a stack. Consider the third example. What data structure is used to represent the Google Maps navigation system? A Google Maps navigation system has a lot of places and roads connecting them. This can be represented using a graph where the places denote the vertices and the roads connecting them are the edges. Some of the common algorithms on them are insertion, deletion, and finding the shortest path between two places. Example 4. What data structure is used for CPU scheduling? What do we mean by CPU scheduling? A processor continuously gets requests from multiple processes to get its time in the processor. There is only one processor, and how does the CPU decide which process should get the processor to complete its work? One possible data structure that we use is typically a queue, wherein the first process that asks for the processor is given the processor. Fifth example, what data structure can be used to check if the English sentence is grammatically correct? A parse tree or a tree structure is typically used to check if a sentence is grammatically correct. For example, the root sentence, it has two children, noun phrase and verb phrase. Noun phrase is composed of article and noun, wherein a verb phrase is composed of a verb and noun. The last leaf nodes are the actual words in the sentence, and if they conform to the syntax mentioned in an English sentence, which is represented using a tree, then they are grammatically correct. This concept is also used by compilers to check if the syntax written in a given programming language is correct, to check if the arithmetic expression written is correct, and so on. Let us differentiate linear and nonlinear data structures. Consider an example where we have a linear list, that is, from A, which element can I move to? From the diagram, it is obvious that from A, I can move to B. From B, I can move only to C. From C to D, D to E, E to F, and F to G. Is it possible to say that the element following B is D? There is no way a person would consider that D is the element following B. There are very strict rules that the successor for B is C, that is, the element that follows B is C, and the predecessor of B, that is, the element before B is A. There is never a confusion as to what should be the next element and what should be the previous element. We can reach only one element directly from an element, and the relationship between the data is strictly one-to-one. This kind of a data structure, where we have seen in arrays, lists, stacks, and queues, is called as a linear data structure. What data comes after Java? Island, coffee, or language? Here there is an ambiguity or the unsurety whether island is after Java, or coffee can be said to be after Java, or language is after Java. In other words, I can reach more than one element from Java. In this case, there is a one-to-many or many-to-one or many-to-many relationship, and this kind of a relationship or this kind of a data structure is typically seen in trees, graphs, files, sets, and tables, and they are referred to as nonlinear data structures.